So you had to figure out some exact values for some half angles. All right. Okay. Yes. It's on the sheet that you already have. It's on the bottom part. It's half angles. Okay. Now, for you guys that weren't here yesterday on your field trip, I did video and YouTubed it. Okay. All right, come on, we got to go because I got a lot of stuff to get through with you today. Any questions? Okay. All right. So let's move on. We're going to do some more half angle stuff. Now, let's start off, and I've changed up the assignment a little bit from yesterday. We're going to look at kind of half angles from like a triangle problem, sort of like we did with double angles. Okay, I remember how we did, like, for instance, numbers 1 through 6 on the triangle problems, on the double angle problems, how we filled in the double angle formulas with ratios from my triangles. Okay, we're going to do the same thing, except for we're just going to do it with half angles. Okay, now I'm going to make up, or I'll just do 47, 48, and 49 here. And so they've got an easy triangle, an easy 3, 4, 5 triangle. My old one broke. It was like shorting out on me. I don't really like this one. I feel like I should be asking you if you want fries with that or something. Do you like fries with your half angle? All right. Now, so let's look at, I'm going to look at with you 47, 48, and 49. Okay, and that should really help you do 50, 51, 52. Now, so what they want you to do here is they want you to find the half angle for sine. Okay. All right. So I'm going to use my half angle formula. All right. So we'll get, and let's think ahead of time. Y'all look at our half angle formulas on the left. Okay. What's the thing besides the sine that we really have to find in the half angle formulas? The cosine. So that's what all I'm really going to need off the triangle is what is the cosine. Okay. So what's the cosine of theta up there? Yeah, 4/5. All right. So now let me write down my formula. It's plus or minus the square root of 1 minus, now instead of a, I'm going to say theta because that's my variable this time, over 2. All right. Now, with the triangle problems, if I don't have that I'm like in a certain quadrant, if it's just a plain old geometry triangle, everything's positive in it. I don't have to worry about signs. So guess what's going to happen on this side? It's positive. How did we get the sign yesterday? Well, it depended on the quadrant. Well, if I just have a plain Jane triangle, everything's positive and I don't have to worry about what quadrant that I'm in. So it makes these problems a little bit easier because you don't have to deal with that. It's just positive. So now all I'm going to have to do is fill in right here what the cosine of theta is. And so we already found it because I knew that I was going to need it. So let's put that in there. So it'd be square root 1, now minus, what is the cosine theta? 4/5. All right, over 2. Now all I have to do is clean it up. Now remember yesterday, if we multiplied by 2, it cleared out the fractions. What am I going to multiply by here to clear out the fractions? 5. Okay, and that's going to be easy to do. So we'll multiply everything by 5. So we'll get a big old square root of 5. Now what's going to happen right here? I'll cancel. Okay, minus, and that's just going to leave me with 4 over 10. Okay, now 5 minus 4 would give me 1. So I'm looking at the square root of 1/10. Okay, now let's see if you guys know, how do we do the square root of a fraction. Right. Square root of the top and the square root of the bottom. Square root of the numerator and the square root of the denominator. So what's the square root of 1? 1. Now, square root of 10, 10's not a perfect square. So it's just square root of 10. Okay, and so notice that you're going to have to rationalize that. So it's going to give you, what, square root of 10 over 10. Okay, talk to me. Did y'all follow everything that we did there? I think one of the things you're going to have to realize is this step right here is you get rid of the fractions right there. You multiply by the common denominator, which is just going to be whatever this number is. Now, on 48, I'm going to take a shortcut by using what I had on 47. Okay, on 48, we're doing the cosine of the half angle. Okay, so let's look at this, and you'll probably see a nice shortcut here that we can use. Now, the formula for the cosine half angle is 1 plus cosine theta over 2. Now, here again, because it's just a nice plain Jane triangle and it's not on the coordinate plane, what's the sign going to be? Positive. Okay. Now, what's the difference here? It's the only difference in my formulas now. Yeah, this is minus and this is plus. So what I'm going to actually do is use this problem to help me out over here. So at this point, what would the only thing that would be different here? This would be plus. And so instead of giving me 1, it would give me 9. All right, you see how y'all can shortcut cosine if you have sine? All right, so this is going to give me square root of 9 over 10. Okay, now, so let's think about the fraction again. We do like she said, the square root of the top and the square root of the bottom. The square root of 9 would be 3. And the square root of 10 is just going to be square root of 10. Okay. Now, if we rationalize this, this is going to give me 3 square roots of 10 over 10. All right. Now, we're also going to shortcut number 49 from these two things. Now, remember I told you yesterday I gave you, there are half angle formulas for tangent, aren't they? And I told you, like, on these problems, from 39 to 45, the ones where you weren't using triangles, that you would use the half angle formulas for tangent. But here we're going to use a shortcut. What do you think I'm talking about the shortcut's going to be for tangent? Sine over cosine. Okay? So on number 49, for this one says the tangent of theta over 2, instead of using that tangent formula, for these problems, for my triangle problems, I'm going to use my shortcut. Now, my other problems, I'm going to use the actual tangent formulas. Okay? But tangent of theta over 2 would just be the sine of theta over 2 over the cosine of theta over 2. Okay, so let's look back. What do we get for sine theta over 2? Yes, square root of 10 over 10. Okay, and then what was the cosine here? 3 square roots of 10 over 10. Okay, and this happened with double angles and some indifference formulas, all the same, didn't it? What always happened there? The denominators would just cancel. And notice something else is going to cancel out pretty nice for me here too. Square root of 10 over 3 square roots of 10. And so the square roots of 10 would cancel. Now that's not 3 though. It's 1/3. Okay. All right. Now, talk to me through these. You want to do another example with another triangle and find all the half angles with it? You want to do another one? Okay. All right. I'm going to make this one up. All right. Let's say this is 5, 12. Let's call this alpha. Okay. So let's do this. Let's find the half angles for sine, cosine, tangent. Okay, so in the formulas, again, what's the main thing I need off my triangle? The cosine. Okay, because that's what's in the half angle formulas, is the cosine. So what is the cosine? All right, what am I going to need there first, though? Yeah, the hypotenuse. All right, so the hypotenuse would be, that's a triple, 13. Okay, so now tell me what the cosine is. Yeah, 12 over 13. Okay, now let's go to plugging in our formulas. So let's see, let's find the sine first. So let's find the half angle for sine. All right, so this is plus or minus the square root of 1 minus cosine alpha. That looks like a 2. We'll do it like that. Over 2. Now, all we got to do is plug in this. And how come I'm not, remember I was really uptight about the sine yesterday? I'm not uptight about it right now. Why not? Right, they're all positive. Okay, it's just a plain Jane triangle. It's not a triangle in the chord plane. So it's just going to be positive there. Now, all I have to do is plug in the cosine of alpha right there. Is just plug in that 12 over 13. So we get the square root of 1 minus 12 over 13 over 2. Okay, now, how can we clean it up? All right, multiply by 13. Okay. All right, so 1 times 13 is going to give me 13. All right, now what's going to happen here? Right, they'll cancel and just give me 12. And then this will give me 26. All right, now 13 minus 12 is going to give me 1. So I'll get the square root of 1 over 26. Now, with the fraction, we just do the square root of the numerator, the square root of the denominator. Now, what happens on these? The numerator, for some reason, I can't figure out why. I wish I could figure it out. It always comes out a perfect square for some reason. I think it's because you're using triples, probably. Okay, but that's just going to be 1. Now, 26, I don't think we can simplify that. It's just square root of 26. So now rationalized, it's going to give me square root of 26 over 26. All right, now let's do the cosine. All right, so cosine of alpha over 2 equals. Now, again, what's the only difference in the formula? This is plus. So right here, instead of 1, it's going to give me what? 25. All right, so I'm going to really shortcut it here. And so this would just be the square root of 25 over 26. And so the square root of 25 is going to give me 5. Okay, so I'll get 5 over square root of 26, which would be 5 square roots of 26 over 26. All right, now tangent. We're going to shortcut this one too. Okay, we're going to do what for the tangent here? The sine over cosine. Okay, so what's going to happen with the 26s? Yeah, they're going to cancel. So it's just going to be square root of 26 over 5 square roots of 26. So they'll cancel. So right, that's not 5. That would be 1/5. Okay, y'all follow those? Okay. All right. Now let me stop and save, and then we're going to look at another thing. Okay. Hang on. Let's go get